Welcome back to the AI Research Roundup. I'm your host, Alex. Today, we're discussing EdgeTAM, On-Device Track Anything Model, a paper from January 13th, 2025. This research aims to make the powerful Segment Anything Model 2, or SAM2, efficient enough to run directly on mobile devices. Now, the Segment Anything Model 2 is excellent for video segmentation. That's the task of identifying and tracking objects frame by frame in videos. The researchers discovered that the Segment Anything Model 2's memory attention blocks, which are components that help the model recall information from previous video frames, were a key performance bottleneck. So EdgeTAM introduces a novel 2D spatial perceiver to process these memories much faster, and it also uses a distillation pipeline, which is a clever training technique to maintain good performance even on phones. Alright, and for those interested, the team has also released the code. On GitHub, you'll find their official PyTorch implementation. PyTorch is a common AI framework. The repository includes the core code, example notebooks to get you started, model checkpoints, saved model states, and even a Gradio demo to try out. Okay, so this first figure really highlights the speed versus performance trade-offs. On the vertical axis, we have axis, we have F on SAV val. Now, J and F is a common score, combining measures of how accurately objects are outlined and how well their boundaries match the ground truth on the SAV validation dataset, which is a challenging video dataset. Higher J and F is better. The horizontal axis shows frames per second, or FPS, basically how fast the model runs, on both a powerful NVIDIA A100 graphics card in blue and an iPhone in red. We can see EdgeTAM, shown by the diamond shapes, is dramatically faster on the iPhone, 22 times faster than the original Segment Anything Model 2, while keeping a very similar J and F score. Okay, so digging deeper than just overall speed, this figure breaks down the single frame latency. That's the processing delay in milliseconds on an iPhone. Part A looks at different image encoders, the parts that first process the visual input. We see that even with faster image encoders, the decoder, which generates the final object outlines, is still a bottleneck. Then Part B examines the internal components of the Segment Anything Model 2, especially within its memory attention blocks, revealing that cross-attention, or CA, a mechanism for combining information from different sources there, is the primary slowdown. This analysis really pinpoints where the performance hit was coming from. So building on that understanding of where the slowdowns occur, this figure lays out the overall architecture of EdgeTAM. We see video frames processed by an image encoder, then memory attention, and a mask decoder which creates the object outlines, helped by a prompt encoder for user inputs like points or boxes. The critical new part in the orange box is the 2D spatial perceiver. After a mask encoder processes the current frame's mask, this 2D spatial perceiver compresses those features before storing them in the memory bank. This compression, using internal mechanisms like self-attention, a process where the model weighs the importance of different parts of its own input, is key to speeding up the memory attention for future frames. Okay, so we've seen the architecture of EdgeTAM with that new 2D spatial perceiver. This figure now shows us how EdgeTAM is actually trained using a clever process called knowledge distillation. This is where a smaller, more efficient student model learns from a larger, more powerful teacher model. Part A depicts the image segmentation pre-training stage. Here, the student's image encoder, shown as a white box, tries to match the features from the teacher's image encoder, in gray. Both are also guided by a task-specific loss, L_task, which measures how well they perform the segmentation. Then, Part B shows the video segmentation training stage. Here, the student model additionally aligns its memory attention module's output with the teacher's, again using specific losses to guide this mimicry, all while still learning the main task. Alright, so after understanding how EdgeTAM is trained through that knowledge distillation process, this next figure, figure 5, shifts our focus to how well it actually performs. Specifically, it's looking at zero-shot promptable video segmentation accuracy. Now, promptable video segmentation. PVS is where the model outlines objects in a video based on some initial user guidance, like a few clicks. And zero-shot means it's doing this on datasets it hasn't seen during its specific PVS training phase. The vertical axis again shows the J and F score, our combined accuracy measure, and the horizontal axis shows the number of initial frames where the user provides 3 clicks to identify the object. We have 2 plots, A for offline settings, where the whole video is available, and B for online settings, processing frame by frame. EdgeTAM in blue consistently performs very well, staying competitive with the much larger Segment Anything Model 2 and Segment Anything Model 2.1, and outperforming other combined approaches, like Segment Anything Model with XMEM++ or Qt, especially as more initial guidance is provided. Okay, so we've seen EdgeTAM perform well in promptable video segmentation. Now, Table 1 here shifts to zero-shot accuracy on the broader Segment Anything task, which includes general image segmentation across 23 different datasets. It reports MIOU. That's mean intersection over union, a score that tells us how well the model's predicted object outline matches the actual outline, with higher numbers being better. We see scores for 1-click and 5-click user prompts. While EdgeTAM's MIOU is comparable or slightly lower than Segment Anything Model 2 and 2.1, especially when they use their own data mixes, look at the FPS column, frames per second. EdgeTAM achieves an impressive 40.4 FPS on an iPhone, a massive leap from the 1.3 FPS of the Segment Anything Model 2 variants. This really highlights its efficiency. Okay, building on its general segmentation speed, Table 2 here focuses on video object segmentation, often called VOS. This task involves tracking and outlining a specific object throughout a video, usually after it's pointed out in the first frame. We're looking at accuracy using the J and F score, which we've discussed, and a G score for the YTVOS dataset across various video benchmarks. EdgeTAM posts strong results, like 87.7 J and F on Davis 2017. While Segment Anything Model 2.1 is slightly ahead in pure accuracy here, EdgeTAM is still very competitive. The real story, though, is the speed. On an iPhone, EdgeTAM hits 15.7 frames per second, blowing past the less than 1 frame per second of Segment Anything Model 2.1. This huge speedup is what really makes EdgeTAM stand out for practical use on mobile devices. To wrap things up on EdgeTAM, it's clear this model makes a huge leap in bringing powerful, interactive segmentation and tracking to everyday devices. The key takeaway really is that incredible speed on mobile phones, without a major sacrifice in accuracy. This opens up so many possibilities for real-time AI applications directly in our hands. Alright, that's all for today's AI Research Roundup. Thanks for joining me, I'm Alex.